Today, I will introduce a new video generation model called One-To-All Animation. The biggest feature of this model is pose migration, or pose transfer. Judging by appearance, the current video generation effect is superior to Wan Animate. It has a major feature: it can apply images from any perspective to different poses. For example, this is a multi-half body perspective, and this is a full body perspective. This does not result in distortion due to the inconsistency of the pose character or the overall perspective. These are examples I tested. Take a look. Judging by appearance, its effect is indeed better than Wan Animate, with fewer artifacts. Furthermore, as the video length increases, the quality of the character does not degrade. Another significant feature of this model is that it can be infinitely extended, meaning it can generate videos of any length. Next, let's look at this example. The total video length approaches 30 seconds, generated using a single workflow. Note that as the video progresses, you will find that the action migration remains very perfect. This is unlike many models, where the longer the duration, the blurrier the character becomes, and the image quality noticeably decreases. What you are seeing now is the GitHub page for One-To-All Animation. It currently offers two model versions. One is 1.3b and the other is 14b. If you want to use this model within ComfyUI, you can use KeyJai's One video extension. You can open the example workflow folder and find a file like this. This file is the sample workflow for One-To-All Animation provided by KeyJai. Regarding model downloads, it still offers two versions. One is the FP16 version and the other is the FP8 version. You can choose a different model based on your computing power. Here, we will choose the FP8 version. Similarly, I have also built the workflow on Running Hub. You can access this platform through Running Hub. In the ComfyUI domain, Running Hub is a fantastic online working platform because whenever new models or new extensions appear, it follows up immediately. You can use the invitation link in my video description area to register for Running Hub, which grants you 1,000 free credits. Additionally, you get 100 points gifted every day you log into Running Hub, allowing you to test your own workflows. What you are seeing now is the original One-To-All Animation workflow provided by KeyJai. It can generally be divided into two parts. The first part generates a base video. The remaining parts are collectively called the extension parts. Each extension continuously extends the length of the video downwards. Therefore, based on this idea, it can generate videos of infinite length. Now, let's look at the basic structure of this workflow. Since we are performing pose migration, first, we need to provide a reference image. Second, we need to provide a driving video. Then, they are resized according to the set resolution. The most important step here is to extract the pose. The extraction node uses another extension by KeyJai called Wan Animate preprocessor. For this node, we need to pass a model. Note that within this model, there are mainly two models. One is for pose extraction, and the other is a YOLO visualing model. If you are unfamiliar with this part, you can open the extension address. There are very detailed descriptions regarding the download address for each model and the local directory where it needs to be placed. Additionally, we need to connect the driving video to the image input and the reference image to the reference image input. We will then get four outputs. To make it clearer, let's display these four output items. Now we can see all four outputs. The first is the pose image, which is essentially the pose extracted from the video. The second is called the reference pose image, which is the pose extracted from the reference image. Below that is our reference image. Further down, there's the reference mask, which is a mask. Since we haven't performed any processing on the image yet, this mask is basically empty. It is a completely black image. But you should note that although this mask is empty, we use this mask as a key input in the workflow. Next is model loading, which is quite standard. First, our main model loads the One-To-All Animation FP8 model we just mentioned. Then, we load a Light X2V acceleration model with block swapping enabled, and the quantity is set to 32. Then we load the VAE text encoder. Note that the prompt can be very general. Since we are testing dancing videos, my prompt is written as "a beautiful girl is dancing." Then there are some basic configuration items here. For instance, our current frame count is 81 frames. But you must know that these 81 frames mean we generate 81 frames at a time. Not that we generate only 81 frames in total. Similarly, since it involves continuous expansion, there needs to be a certain overlap between the previous video and the next video. We set the number of overlap frames to 5. What is interesting here is Kijai's design regarding the scheduler, which is actually a dynamic schedule. You will find that this scheduler produces a certain curve based on our steps. Below we enter the base video generation part. There are two very important steps here. The first step is called One-To-All Reference Embed, which is actually adding the image information into our latent space. And another one is called One-To-All Pose Embed, which is actually adding our pose information into our latent space. How does it work specifically? Let's take a look. First, we generate an empty embedded vector. You can think of it as an empty latent. Then we go to our first node called Add One-To-All Reference Embed, which is essentially adding one vector to another vector. The base vector to be added to is of course the empty vector we just set. Then what do we add? Note that one is our reference image and the other is our reference mask. Therefore, through this node, the relevant information of our reference image is added into our latent space. Further down, we need to add our pose into this embedded vector. We first need to extract 81 frames from the pose because we cannot generate the entire video at once. For the first generation, we only generate the first 81 frames. After that, we use this node. Note that its input is actually the input we just generated, as well as the pose images we just mentioned. Note that there are two pose images. The first is the pose image from the driving video we just mentioned, and the second is the pose from our reference image. Below that, we just perform sampling. The various parameters for sampling are already defined here. That is the main part. So we first generate a base video. Take a look. The generation effect is excellent. This is the first part of the workflow we mentioned. The rest is expansion, and each step is similar. Let's see how it differs. We first take the video generated in the previous step. First, we have an auxiliary calculation node. What does this node do? Because our video has 5 overlapping frames, therefore when processing the original video, we must remove the last 5 frames. Through this node, it is very convenient to obtain the video after removing the overlap, as well as our starting image. This then goes through this node to be encoded into our latent space. Similarly, these two crucial nodes will be used, which we already discussed. One adds the reference image information to the latent space, and the other adds the pose information to the latent space. Then we perform sampling again to expand the video. After expansion, we need to splice the original video with the new video. We still use the auxiliary calculation node. The difference is that new image is not connected here because no new video is generated. And here, because two videos need to be spliced together, the original video is the one we generated previously, and this new image is the new video generated by this sampling round. After that, there can be a second and third expansion. This node has two very important options. The first is called frames processed, which is the total length of all videos you have generated previously. Therefore, as expansion continues, this value continuously increases. The other option below asks what we should do if the frames are insufficient. The mode currently selected is pad with last, meaning it extends based on the last frame. Therefore, there will be some still frames at the end, meaning they are static. Why does this problem occur? Mainly because this workflow is non-automated. You need to design how many times to expand based on the total number of frames loaded. If the matching is unsuitable, this situation will occur. This is a detailed structure of the workflow. Relatively speaking, it is quite complex and uses many nodes. So everyone, you must clarify this line of thought. Also, note that this model still has certain drawbacks. Let's look at this example. In this example, the driving video has not changed. Note that this image is quite peculiar. It uses a special art style, which is what the Chinese commonly call shadow puppetry. If I use an image like this as the reference image, look at the generated effect. Note that the entire character is essentially redrawn. It does not completely generate according to your reference image. Therefore, this is an issue you need to pay attention to. Do not choose overly unconventional reference images. You should stick to common images. We just mentioned that this workflow is a non-automated workflow. You must manually match it. Therefore, I have also built a fully automated workflow for everyone. Let's take a look. The initial processing is generally the same, but I have now extracted the total number of frames called total count. After generating the base video, I have an automated expansion below. Here, we use a loop. This loop uses for loop start and for loop end. Then, we calculate how many times to loop. We have calculated the number of loops more than once. This is the total number of frames, and this is how many frames are generated each time. Then we first divide the total number of frames by how many frames are generated each time. After that, we subtract 1. Why subtract 1? Because you have already generated once here. Then we perform a ceiling operation. The following flow is actually fixed. We connect the video generated each time to initial value 1, which corresponds to value 1 here. The process below is the same as the expansion we saw earlier. The only difference is that during the final generation, we need to update it to value 1. That is it. Let's look at the final generated effect. It is the same as what we saw earlier. It still has still frames at the end because we chose pad with last to see how long of a video this model can generate and what the generation quality is like. I also used a very long video. I have selected 480 frames. The reference image is a beauty in a trench coat. Let's look at the final generated effect. This is the 28-second video I just demonstrated to everyone. Its generation quality does not show a noticeable decrease with expansion. Therefore, I think the quality of this model is excellent. However, you must note that the preservation of consistency still poses a problem. If you carefully compare the character in the generated video with the character in our reference image, the similarity in consistency is not particularly high. Of course, what is this related to? It is related to the perspective. If the face occupies a larger proportion of pixels in the generated video, the consistency will become very strong. But for full body videos like this, it can generally preserve the overall features. But the consistency of the facial features is not that perfect. This is also something everyone needs to pay attention to. In any case, after many tests, we can indeed find that the quality generated by this model is indeed superior to Wan Animate. I recommend everyone try it. Alright, that is all for today. Follow me to become someone who understands AI.